Hey, Alan, how are you today?
I am doing fantastic.
Well, that's great, man. Hey, you know what today is, right?
What's today?
Today is our favorite day of the week. It's a Wednesday. That means we're doing something. And today is our fourth episode of our virtual workshop. As our attendees come into the session, I just want to welcome everybody. Thank you so much for being here. If we haven't met before, my name is Jeff Nepper, and I'm joined by my partner, Alan Ray with Integrate Live.
Hey, you're in a new place, Jeff.
Yeah, it's been a crazy week. Came back from ARC Forum and then went directly into a move. And this is the new home office, currently surrounded by boxes on the other side of the camera. So looking forward to trying to put our touch on it over time, but going to be a lot of white wall in the background I'm thinking for some time.
Speaking of crazy, did I tell you I burned 2,000 calories last night?
Did you?
I completely forgot the brownies were in the oven, but yeah, I won't do that again.
That's great. Well, I think I'm going to save that for a little bit later because I've got something serious I want to talk about. We need to celebrate. We've got some great news to share with everybody. Alan and I, because of the generous and consistent budgeted giving of our sponsors, have been able to bring on our first team member with Integrate Live. And so I'd like to introduce everybody to Jen Lemker. Jen is joining us on the team. She's going to be working as our strategy and event coordinator part-time. And so many of you will get to see Jen in upcoming sessions. In fact, Alan, she's going to make an appearance on our rundown next Wednesday, same time.
Awesome.
Yeah, so Jen's got an awesome background that's going to really add value. She has spent 7 or 8 years previously working for a system integrator in the Chicago area, INS. And with INS, she spent a lot of time working with their GE install base. And so she understands a lot of the pain points from that industry 3.0 perspective, specifically those legacy GE systems. And so I really think she's going to add value for our audience.
Yeah, she's already taken off quite a bit of stress and load off of us. So she's doing great.
Yeah, absolutely. So Jen, if you're listening, we're excited to have you on board. Thank you for joining us. And we can't wait to see how you make this better for everybody. Jen's actually got some really cool hobbies. She's a bit of a maker. So she loves restoring old furniture. I think she has a lean towards mid-century modern. And she right now is working on taking a farmette and revamping it. I think she said she was building a chicken coop and has goats coming, all this fun stuff. We'll learn more about that in upcoming sessions. All right, so hey, we're joined by our guides, our friends over at Vertech. Chris, Brandon, welcome guys, how are you?
What's up, Jeff, Alan, everybody? It's good to be back. And so it's my turn for the dad joke, just throwing it out there. Do you know where Captain Hook buys his hooks? At the secondhand store.
Oh, geez, that's good. I like that.
Brandon. My first time here, but great to be here. And then why did the football coach go to the bank? To get his quarterback.
Yeah. Brandon's a industrial programmer for Vertech, so he's got that engineer's mindset. Brandon, I don't know if you ever heard of have like a pessimist and an optimist view of glass, half full, half empty. Do you know how the engineer views that glass?
How does the engineer view it?
Yeah, twice as big as it needs to be. So Chris and Brandon have got their work cut out for them today.
I'm sure there's no engineers on this call that are offended right now.
Not at all.
Or listening.
I think it's about as true of any joke I've ever told. You guys have your hands full today, but you've got a great tech alignment to really focus on today's how do we integrate historic, real-time, and transactional databases so that we can get it ready for analytics. Why don't you go ahead and introduce who's joining us today?
Yep. So Kyle, let's start with you.
Yeah.
You're here all the time. So people should know you by now, but if you don't, you need to meet Kyle.
Yeah, no, it's nice to be here. So, I'm from a small town in Pennsylvania, and everybody's all fired up because our local high school baseball team is playing for the state championship on Friday. And so it got me thinking, why are baseball players so rich? Well, it's because they play on diamonds.
And on that note, let's introduce Lenny from Flow, also a good friend.
Hi. Hi, everybody. Lenny here. Sure, you guys are putting me on the spot. First time that I'm on Integrate Live, and I'm already have to think of a dad joke here. So what type of shoes does ninjas wear?
I don't know, what kind of shoes do ninjas wear?
Sneakers.
Sneakers.
All right. Thanks, everybody. All the way from South Africa. Very humbled to join you guys on this talk, and hopefully we can build something really amazing here this afternoon. So thank you very much for the invite. I hope this is not the last, though. I've got some spare dad jokes in the closet, so we'll bring them out later.
Thank you, Lenny. And we also have Vaughn with us from Flow, who's going to be here more for the QA portion of the session. But really glad to have you, Vaughn. If you want to introduce yourself.
Yeah, thanks. I'm also really happy to be with you guys on Integrate Live, joining Lenny for the first time here. And yeah, you have put me on the spot. I'm not one for dad jokes. I usually just give advice. I gave my wife a piece of advice the other day. I said she should embrace her mistakes. And so she hugged me.
You just told Alan's favorite joke, I'm pretty sure.
Yep.
Well done. Well done.
Good choice. Good choice.
All right. Well, Chris, Brandon, thank you. We're going to come right back to you first, just in case this is your first time joining. Thank you. We're glad to have you here. Alan, if you would walk us through what Integrate Live is all about.
Yeah, so we really put this thing together for the hopes of bringing together end users, integrators, and vendors. What for? Why? To bring about a community that is united really under three common themes. We want to be united under the openness, so that we are willing to not just share what we're doing or what products we have or things, but really be able to share, techniques and solutions. And then we want to be transparent. We don't want to show you something and not tell you what it's going to cost. So at the end of this, you'll see all of everything that we used in the stack today. You'll get to see what the cost is if you were to go and deploy this. And lastly, we want to be humble. We know that we don't have all the answers. We know that there are people out there that have way more experience and way more knowledge, but together, collectively, we can help each other, not just improve our individuals' lives, but also the companies we work for. And going to adding value to not just, again, the individual, but collectively, we all get to improve, learn knowledge, and our companies improve. So
That's right.
stumbled over that well.
Yeah, hey, it's okay. We're rusty. And that's fine, because that's what we're all about. And I'm really excited to announce that we have not just, this is our vision, but more and more companies are embracing this vision. And so we've announced before about Software Toolbox joining us. So what does this mean? It means that they are helping fund this effort. Canary and Flow Software have done the exact same thing. They've done it since the beginning. We just didn't publicize it. And now Opto22, Kepware, and Phoenix Contact, all three have also pledged to sponsor and are now actively sponsoring Integrate Live as well. So we're extremely excited. We're very, very grateful, and we are humbled that these companies have all invested in this project. So thank you so much. Alan, we're going to learn a lot more about Software Toolbox and Opto and Kepware and Phoenix Contact's offerings as we look to solve more problems that include them in our tech stack.
I'd also like to just point out that, the part about openness, right? I mean, you look at these vendors on here and they're competitors. They're not just, hey, I do this, I do that. No, they're competitors. And some of the feedback that we've gotten from Opto and Phoenix and Software Toolbox dealing with, their competitors, they're excited And they're also being very careful. They're like, hey, I don't want to do anything that's gonna bring frustration. And we have the exact same thing happening on the other side going, hey, we just want to be a part of the community and we want to help. And so it's awesome.
Yeah, we're super grateful that they have joined us, and the only reason that they have joined us is because they share those common values. There's going to be companies that are going to want to join that unfortunately we're not going to be able to have them because they don't have those common value threads. And it's been an awesome ride, and we can't wait to see now with these financial contributions where we can go with this. So thank you. Hey, speaking of where we're headed, we've been talking for the last 3 episodes. We're going to continue in this 4th episode talking about data points, the value of a data point as we move from the creation of a data point to obsolescence. And today we're really going to shift and move to the back half of this value chain. So we're going to be talking about on the enterprise level, much more focus on the enterprise level than down at real-time control and site level. Chris, Brandon, take us through a little bit, if you would, on our business use case today.
Yep. So words and statements, sometimes they sound too cliche. Today, the point is that we're going to be talking about analytics. So as Jeff said, this is up on the enterprise level. And so the real use case here is where people are struggling with getting the data to align. So this is talking about normalizing and contextualizing that data so that those analytics are possible. And Jeff, if you'll advance. Yep, keep those in there. So the main areas that we're going to talk about today is transactional, real-time, and historic data. How do you merge that? How do you contextualize it? How do you make sense of it so that you can actually do analytics? And then how do you get it back out to other applications through open APIs, standard protocols? And is it going to take a lot of work? Hopefully not, because we're doing this in like half an hour. So you are going to see this legit from the start of it to the completion of it. And yes, these are experts. If you've ever worked with Kyle or Lenny, they could just run circles around people. But at the same time, it is going to be documented on video, and you'll be able to see exactly how they got to this point and be able to prove this business use case.
Yeah, and it's there's a lot of different ways you can solve this problem. It's trying to solve it at scale that has been the challenge, right? So many enterprises are failing at doing this because they just don't have a scalable solution. I'm excited to see what everybody does today.
Right. Ooh, and it breaks up into 4 pieces of animation so that I can talk about them individually. So we're going to be talking about this pyramid today. And starting from the bottom, descriptive is the most basic sort of analytics that you do. So think of historical data, think of a trend, think of a chart. You're able to see what happened. The next level up is answering the why. And so sometimes this is through the use of KPIs. Sometimes this is anomaly correlation. Sometimes this is notes by a person put into a screen. And all for the purpose of answering why, but still a very manual process. The next step up is predictive. And this is where we start getting into machine learning and statistical methods. We will show off a little bit of this today. And then the holy grail up at the top is prescriptive. It's a very small word in this diagram here because it is very difficult to get to that level. But we're going to show you, not necessarily today prescriptive, but talk about how it feeds into prescriptive analytic efforts. And so this is when it gets to full ML, AI type analysis. Brandon?
So part of the issue with working your way up that analytics continuum is the effort that's required to get there. So speaking from experience, a lot of the time that I'll spend working on a project is you're trying to get the data, you're trying to wrangle the data, you're trying to clean it, make it look right, chasing down issues when it's in a word instead of a number. All sorts of issues that you're just trying to get to a point where you can start doing things to help improve your business sense with that data. So part of what we're going to address today is taking that, as shown here, the 80% preparing and managing your data as compared to the 20% adding, and helping shift that, where you're spending a whole lot less time getting a handle on your data and cleaning it, and a whole lot more time getting something out of your data. So some of the reasons that go into that huge 80% is data is hard to access. You spend a whole bunch of time chasing down security things or trying to talk the right people into letting you actually access the data, whether or not it's in a format that maybe doesn't connect to what you're already using. It has missing pieces, or kind of like I mentioned before, it's stored in strings and integers and all sorts of different values that don't tend to play nicely with one another and can cause issues. So part of where we're going to take that, if we go to the next slide, Jeff. Oh, sorry.
And these are the added slides.
Yep.
Last minute, Brandon. So the thought with this is that right now, this is how people are addressing it, of taking all of your data sources and bringing them up to cloud apps. So whatever that be, Power BI or other types of applications up in Azure, AWS, and just acting like that was enough. And the data scientists are going to just magically going to be able to work within this, ignoring all of the cleansing and the processing that is needing to happen in between. Or this next instance, who here has heard of the magical data lake? This is so common for years and years now. It's like, we just need to get all of our data to the data lake, and then it's going to work out. And I have not seen it work out. This is the fallacy.
That's not true, Chris. It is working out. It's working out nicely for the salespeople, the data lake, because people are getting like 10 to 15.
I must have missed it. It just happened immediately. Like what? Like this month?
Yeah.
Cool. We've got it now. All right. Well, there's a third option for this.
That's right.
And that's kind of the point of today. We're showing you a way. Obviously, there is part of that transparency and that openness. There are other things out there. There are other ways of doing this. This is a way that is used to be able to make this work. And so it is something acting as the hub that is capable of doing all of the translation and the aggregation and calculations management and the modeling, the cleansing, in order to make it possible for those cloud apps and those data scientists to be able to work from it. And Brandon?
And so what we're going to show you today is taking that 80% preparing and managing that data and cleaning it and messing with it and just getting to the point where you can start doing stuff, and turning that percentage way down, where a lot of that is done for you automatically and it's done through set up models. And instead you can spend a significant portion of your time actually adding value, and as well as showing tools that can help you add more value or add it in a more manageable way. So here we have kind of the 5 steps in building a good model or good analytics chain. Some of the items really going to be focusing on today are how to create models. So as you set up a singular model, how can you roll that out to other sites or assets without having to do a whole bunch of additional work? Connecting your data to different sources, both in pulling data into your analytics, as well as taking that data once you've created additional value for it and pushing it back out to somewhere else, something that's already in your business chain. How to transform that data into something that's actually usable, whether that be just doing calculations on it like roll-ups or complex analysis to help pull more information out of it. Visualizing it is not a new thing, but we'll run through some of that today as well. And then how do you bridge between all the different sources of data coming in, going out, different formats, and make it a seamless transition that does it all for you, as opposed to, exporting things in an Excel workbook every day.
And so
today, Oh, go ahead, Chris.
You got
So
this.
some of that technology you're going to be seeing used today on the Canary side. Canary split out into some separate modules. So we'll be using the historian, the virtual views, the calculations and event, and the API modules out of that. And then under Flow software, you're going to be seeing the configurator, transformation services, the visualization server, and also their API server in order to interact with Canary and separate data sources.
All right. Thanks, Brandon. Thanks, Chris. Kyle, why don't you go ahead and kick off your
Yeah, sure.
title there.
So here's an example architecture of something you could be looking at with maybe multiple sites logging up to an enterprise historian. You could have a historian at each individual site, or maybe you're just pushing data up to the enterprise historian. It just kind of frames what we're going to be looking at today when we switch over to the live demo. Now, everyone probably knows that Canary is a historian. That's maybe what you think of when you think of Canary, but today we're going to go beyond the historian feature in Canary and instead look at the historian archive, more into the contextualization of the data, specifically as it relates to tag names, asset models, and calculations. And the first big piece of that will be virtual views. So this allows us to adjust the tag naming structure that you'll find at multiple sites. So at the local level, tag names could be unique, maybe completely random to the naked eye. They may not make much sense, but to the people who work at those sites, they may know exactly what those tag names mean. But once you get to the corporate level and you're trying to make sense of these multiple sites, it's going to be helpful to create an organized and standardized naming structure and do it post-archive to make the analytics much easier. So we're going to log the data into the historian just as it's used at the sites. And then post-archive, we'll go ahead and organize those tags, group them into parent-child asset models. And we'll do this using regular expressions so that it scales very well. And we'll provide some examples of that later on. But once we build out those virtual views and the asset models, then we can start to build calculations based on the asset models that we've built. And these are things like Rollup Calculations. So if we know what an asset type is, it could be an area, it could be a line, there could be pumps that exist in these areas. Then we can look at the asset types and identify the tags that make up those assets and run some statistical calculations based on interval. So for today's example, we are going to look at pumps, and these pumps belong in certain areas so that we can look at the area and say, how many pumps do we have? How many have there been in the last 30 minutes? Maybe what's the average flow of those pumps? Things like that. And these types of calculations you'll build within the Canary system, but the calculations are very powerful because they're not just used within Canary. You can provide that information to third-party applications, and it prevents you from replicating the work further down the line. And speaking of sharing it further down the line, one thing that sets Canary apart is getting data out of Canary. And we always have our API open and unlicensed. And Flow is going to use that API today to read raw or aggregated values out of Canary. And most importantly, that asset model structure that we've created, it gets passed through. And this means that once you do the work inside of Canary, you don't have to replicate it to non-Canary applications as well.
All right, thanks, Kyle, for that introduction. All right, so obviously after we've got the tags nicely organized per asset, that's now where we're going to turn that data into actual KPIs. Now, remember these 5 steps because it's exactly what I'm going to do when I do my demo. I'm going to model it. I'm also going to connect to various different data sources. And really, we've got 3 different classes of data sources that we can connect to. We've got the real-time data sources that we can buffer. That will include OPC UA, connection to MQTT brokers. We've got our historians like Canary that we can connect to, Influx, Ignition as well. So connect to our time series historians, and then also connect to our relational databases. These could be data marts, it could be the data lakes or data swamps, whatever you want to call them. It could be MES and LIMS applications as well. And the whole point is to create a way that we can very easily connect to these different data sources, use them in calculations, and then to create KPIs based on that. And very importantly, is always to have the capability for manual entry. Manual entry is not just to maybe collect data that's not automated at this point in time. It's also there for data correction. It could be used for classification. If we think about a downtime solution, really bringing the human aspect into this as well to add context to the data that we are trying to analyze. Then obviously we're going to go and transform that data. Okay, now this is very important, and this is the part that we try to make as easy as possible for our data scientists, so that they don't really have to try and struggle to connect to a whole bunch of different data sources and try to figure out how to normalize these different data points so that they can do their calculations. So in this example, I've got two data sources, a historian, which will be the Canary for today. I also have a Microsoft SQL database. Now, when we pull the data into Flow, we reference them and we call them tags, right? But as you can see from those points, these tags are not normalized in time. The tags change whenever the timestamp is as from the source. But in order for us to utilize those two calculations, we first need to go and perform what we call point normalization on that. And it's very important. We're not aligning them or bringing them together at one single point. We are actually giving you the value at the timestamp of when each and every one of these data points change. So it's zero data loss. And with that, we can truly do row-based calculations and create calculated tags. Now think about this. We spoke about that we need to clean data, right, before we can actually use it. So we can clean those tags. We can filter it out when the quality is bad or in a certain band. We can look at another data source to look at a different state and only do the calculation when that state is active. And I'm going to do an example like that as well. So the point with these tags is now that I can also utilize these tags and create what we call event context, right? Think about an event as a downtime event or a start of a batch or a start of a work order, because these different events can also supply a whole bunch of different context to the data that's very important to our data scientists when they want to do their analytics. We can also go and use these calculated tags or tags to create what we call period KPIs. A period KPI would be, all right, take the calculation and now create a KPI for the hour or for the day or for the shift that I can actually chase as an actionable action point to try and improve my production. So we'll take these point normalized calculations, we will aggregate them into what we call period normalization. And now the data is in context and a little bit more into a transactional kind of way so that our other solutions might be able to get this data very easily and do their work with it. So we can use this measures or KPIs to do production KPIs. We can roll-ups, we can work out equipment efficiencies. We can bring in data from ERP solutions to work out calculations relating to cost and revenue. And very important, Chris mentioned it, we can also use this to do a little bit of projections and forecasts, especially if we want to try and determine if we're going to end our goals at the end of the day or at the end of the shift. So I'm going to go and demo this today. And obviously we can overlay that event context with that data as well. We store that data. We store the period normalized data. This can now be served with our API or with our visualization, or I can even push it back into Canary for data points there. But the other cool feature that we can assist with is actually get the raw data from all of these different data sources for people to use. So we pass that through. We don't replicate it. We are not in the point of being a historian. That is the job of a proper industrial historian like Canary. But the point is that we can pass these normalized calculations through with our API, that it can be utilized in a Power BI or solution at the end of the stream. So we make these data streams available. All right, then we need to visualize. Yes, we do have our own little visualization capability as well. I'm going to demo some of that visualizations, building up some dashboards and some charting so we can utilize that. And what we can also do is then, very importantly, bridge this out. Again, the whole concept of Integrate Live is that we're not a closed system. We play with other technologies using open standards. So I can push this back to a data warehouse, the now contextualized information. I can push it back to a Canary. I can push it back to an MQTT broker where this data might be available now in a unified namespace, as an example. We also have the capability to inform people around this KPIs and information by doing our messaging and pushing this out to Teams, your Teams channel, or via Slack message or via email, so that people can get information around their KPIs. Again, we have a REST API as well. This can be used to connect the KPIs to the SCADA. Who's better to try and correct or bring you back onto speed than the actual operator pulling the levers on the plant floor? So sharing this information to everybody in the organization can add huge value in trying to drive a profitable operation. Again, we can make it available in Power BI. That's what I'm going to demo today, and have this now clean data available for machine learning platforms as well. We also have the concept of a tiering solution, where we can have multiple instances of flow pushing to a centralized flow instance. Great for doing comparison of benchmarking between your different sites. If you have some kind of HQ or enterprise solution, you want to do those comparisons between your assets on the plant floor.
Lenny, you killed it. That is an awesome presentation. Like 5 minutes of describing a very complex software. And I don't know if it's possible, but those slides were exciting. Like the animation that you were doing through it, was very good. So I just want to encourage all the people in this presentation today, drop some comments, ask some questions of these guys. So you're starting to see what Kyle and Lenny are talking about. This is your moment. I mean, if this was YouTube, we would be asking you to like the video, drop some comments down below,
Hit the
click the
bell.
subscribe, and turn on ghost notifications. But for now, just ask some questions, maybe get some feedback to Kyle and Lenny as they present.
I'll give a little bit of feedback, because I just want to. So we brought Flow in for the predictive piece in Era when I was at Era. And when it really connected for me was when I actually understood the concept of creating a tag out of a moment in time from a relational database. The moment I got that, well, now like, oh, okay, now I have a relational database. I can now have a time series point that I can calculate off of my time series historian, and then I can do modeling and different things. That, for me, that was when the light came on. That was like, oh, this is way more impactful than just being able to do some visualization and get some predictive, shift time. Am I going to make my barrels or whatever it is? So great job, Lenny.
Hey guys, we're not done though, right? Like we're still going to solve this live.
Let's see it.
Dark.
I felt like we were wrapping up a little bit.
I have burnt brownies in the kitchen.
You got burnt brownies. Kyle, get this thing going, man.
All right.
Somebody's asking if you can show that slide again, but
We will.
I think we can. We'll take a screenshot of it and maybe put it in the comments or something.
All
All
right.
right, Kyle, tell us
Yes.
what we're looking at and frame the architecture a bit for us, please.
Yeah, so for this demo we're seeing here, I'm going to kind of play the role of a corporate admin for the system. So we've got multiple Canary historians possibly out in the field, and so they're all logging data to this one enterprise level. Some dual logging is occurring. And this Canary admin tool gives us the ability to manage everything from just one interface. And so if we take a look at our views, we're currently logging here from an east plant and a west plant. Let's see what these tags look like. Now, I don't know what this could be. Maybe people that work at the east plant can make sense of this. We've got the 0, 1, 0, 0, 2, 0, 0, 3, 0. So there is some kind of structure, but just at face value, it's tough to see what that means. When we go over to the west plant, it's completely different. Now, there are a little more descriptions in the tag names, but compared to the East plant, it's still not showing us exactly what we have. So remember, what we want to do, our goal here is to establish an analytics foundation. And in order to do that, we need to create a new virtualized view of the data. We can do that here within the Canary admin tool. Just going to give us a cleaner format to work off of. Now we can choose our source views. So again, we're coming into this local historian. We'll be pulling from the East plant, that West plant that I showed you. And we're also going to be doing some calculations here as well. So we'll include that in our view. All right, so now we have 76 tags. So here are the tags we're looking at, the view name versus the physical name. And so what this tool is going to allow us to do, we can use regular expressions and come in and look for tags or create rules that will capture a certain kind of tag. There are a lot of resources on regex out here. In today's demo, I'm not going to be a regex wizard and fly through this. Instead, we're going to go ahead and bring in these imported rules, which we've already built out for the sake of time. So here we have the rules, and it's going to find and replace and eventually just create more structure around the data, breaking things into plants and areas and pumps. And now you see these child assets, and we have the tags within each specific area at the plant. And this is how we can check everything. So we want to go ahead and create that just to establish our view. I want to create some calculations. Okay. First, we need to give it a name. This is just going to be a pump roll up to the area. We're going to build off that integrate live model. Again, looking at the areas, I want to set this on periodic frequency, and we're going to set the interval to 30 minutes instead of 5 minutes. As you go through building these calculations, if you're ever unsure what a certain field is going to do, if you hover over, it will show you a cheat sheet and kind of help you there. I just want to backfill this data. Let's kick it back to last Monday. This way we have some more context to build around. So now we're going to do the evaluation. We've got a bunch of different functions to choose from. This first one's going to be a roll up. If anyone has any dad jokes, now's the time to insert some more dad jokes while I write in this calculation.
And or Brandon, if you want to offer any commentary during this, since you are a Canary whiz also.
I'd say that calculation he's using right now, that roll up, is probably the most useful time-saving calculation I've come across in all of Canary. As far as being able to deploy any number of things and roll up catches every single one of them. I know we use it across a large number of our projects to help save a bunch of time with calculating things across every single site or asset or repeated item.
Speaking of calculations, you know what you get when you divide the circumference of a pumpkin?
Can't say
Pumpkin
anything.
pie. Pumpkin pie.
Go for some pumpkin pie. So we have this written out. Now we can evaluate it just to kind of double check. And okay, so we're looking good because I was expecting to see 3 pumps, and we see that that's what we have. We can do it for this the East plant, or we can look into any of the other plants just to double check our work. So we have the calculation built. We have the tag that's going to be created for that calculation. Let's go ahead and do a second one. We'll just copy that. Instead of doing a count, it's going to be an average. And we need to change the tag name. It's going to give us the average flow here.
Kyle, I noticed that you're putting an underscore calc on your calculated tags. That seems helpful to allow your users to understand this isn't a log tag. It's just
right. You always want to log these to their own data set, and the more context you can add, it's going to help you down the line. Again, we're creating an analytics foundation here, and that's going to be helpful in the long run. So double check that. We have the flow. Let's go ahead and check another one. Things are looking good. So I want to apply that. And close out. Takes just a moment for it to appear. We have another calculation that Lenny's going to be using. I'll put those into play mode here. And you can see it is backfilling. We've got the calculation status on the side. It's showing how many TVQs we're storing, and it's all backfilling. If we slide back over to the views, now we have the integrate live model virtual view. We have our east plant and our west plant. And now when we look at this, it has much more structure. Here are the tags, the calculated tags that we just created in the historian, and you see those values coming in. So here's that flow calculation. We've got some flow because we backfilled it, so we have some historical data to go off of. So, okay, we've built our virtual view. We ran a few calculations. Lenny, what do you have in store for us?
All right, thanks, Kyle. Cool. So what I'm going to do now is I'm just going to share my screen. Me and Kyle is working off the same virtual machine that we spun up in AWS. So it is exactly the same box that you're going to see now. Nothing different from there. I'm just logged in with my credentials, and obviously I've got the flow configuration tool open. All right, so remember we said that we need 5 steps to create this proper analytics platform, right? Can anybody remember first thing that we need to do in those 5 bubbles that we went through in the presentation?
Seriously, you're going to put us into a test mode?
That was a model.
No, just a little bit of interaction, that's all. All right, but the first thing that we need to do is model, 100%. Thanks, Jeff.
Which is
all right, so
the first one's model. It's model.
Side gig,
okay.
isn't it, Brent?
No comment.
No comment. All
right.
right, Brent. I thought that was your opportunity to shine. Yeah, he's embarrassed. All right, go on.
All right, so for the guys first time seeing the configuration tool, I'm just going to run through a little bit of the explanation. So on the left-hand side, that is where we're going to build this model. All right. Then on the right-hand side is the second part of the bubble, which is the connect part. So we're going to do all our connections on the right-hand side. And for now, the third part of the bubble, which was the transform part, that's going to happen in this big blank editor interface. So that's where we do all the configuration. Let's just talk about the model very quickly here. So I've got a very simple model as for this. I've got a north plant, but obviously I need to get the east and the west plant into this model as well. Now it's very easy to create this model. We use the ISA 95 as a structure or as a guideline. So you have your enterprise, your work centers, and your work units, and we can model it as such. But I can very simply just take the icons here. I can create another folder structure here. So this can be the south plant. And then I can go and say, okay, you know what do I want to measure for this? So we spoke about pumps. So just to frame that a little bit, we've got a water treatment plant, just as an example. And the end of the day, the KPI that we're looking at is what is my projected water that can be treated out of this plant. So that's the end goal. So when I model this, I'm going to model it in the sense of that KPI structure that we're going to try and figure out how much water can I actually treat out of this plant. So I'm going to add what we call a metric. The best way for me to explain what a metric is that's the what. So that is the what. That's the KPI that I'm looking at. It is total water treated. So that's my metric. And then how do I get to total water treatment? That's all the different KPIs and calculations that I need to do to get to my actual answer, which is the metric. So I'm going to add a metric in here, just rename that. And this is going to be my water treated. So that's what I'm actually want to look at. So it's very simple to build out this model here. You can see I'm doing it by hand. For the first part of the demo, I will do that. It does not solve the whole scalability issue, and we will address that when we do it a little bit later. But the point is I can go and build out my model with the KPIs. What I do want to mention at this point is that this model is totally abstracted from the sources where it's coming from. I do not create my model because I know I'm going to have tags from Canary, I'm going to have tags from my SQL database, I'm going to have tags from a MQTT broker. It's really around what is the information that's important to me to solve the problems that I have in my organization. So the model is completely disjointed from the data sources. So that's the first thing is we create the model. The second thing that we have in context with the model is obviously the context of time. We do have the capability to associate what we call a calendar to the model. Think about your production run for the year might be January to December. There might be other calendars that you need to take into account, like your financial calendar, etc. So we do have this capability to associate different time as context to the data that we're going to build out in this model. All right, so I know that's a very simple little model. I'm going to expand it while I'm building my demo out here. And the second thing that we're going to do is just connect to some data sources. So I'm going to go to my data sources here. You can see that I've already connected to Canary. I've already connected to a SQL database. The SQL database is my planning database. So that will tell me if my plant is, or my different pump sets that I have is actually scheduled to be operated. So it's a little bit of a scheduling system. Just check if those things are scheduled to run or are they in planned maintenance mode or whatever the case is. So I've got that scheduling database. I then have my Canary database. Now, very importantly, I've got two views here. Remember that we said that we're going to pull the view and that asset framework that Kyle just built into Flow as well. And that's exactly what we're going to do. We can still look at the raw data sets. So there's East Plant with its raw tag naming structure. We've got West Plant with its wonderful naming structure. But the problem with this is if I want to build something that is scalable, I can't use this because I can't find a common, tag rule that I can auto address these things when I try to build out my information here. So I'm going to definitely be using the view that Carve just done. There's East Plant, West Plant. You can see it now has the exact same naming structure. The only difference is between this front name here. And I'll show you guys how we address that when we actually go and instantiate some of these points. All right, how do I create these things? One of the problems that we framed is that data scientists have to, spend 80% of time just getting data. And the biggest reason for that is data is in silos. So if you've got data in a SQL database, the historian, just think about how you would have done it to get that data out. Who's going to write you those connectors into those solutions? Who's going to allow you to get that data out and do the normalization for you? Now, we've tried to make it as easy as possible. So I can literally go here and create a new connection. So I can create a connection to my Canary historian. I can create a connection to my Microsoft SQL database. I can even go and create a little bit of a buffer connection to MQTT broker. So let's do that. Let's create an MQTT connection. This is now our real-time class of data sources. And literally, we try to make it as easy as possible. So all I have to do here is tell it where my MQTT broker is residing. So I've got an IP address of my MQTT broker that I'm going to connect to. And I can also decide, listen, am I utilizing the Sparkplug B protocol from a payload perspective on that MQTT broker, or do I have some other custom payload that I need to pass through? In my case, definitely Sparkplug. What port is it running on? And then the only thing that I need to do here is decide which nodes or topics do I want to subscribe on. I've got a topic here where I'm pushing some data in, so I'm just going to do that, and that will now subscribe to that specific topic in that scenario. Save this out. And technically what I've done is, whoops, I know it already exists, sorry, integrate live. I have now created a connection to an MQTT broker. Cool. You'll notice that it is red, so it's not active at this point. So what I just need to do is deploy it on the platform where I'm running it so that we can start buffer those data points. So I'm just going to drag it onto my platform here, deploy it out, and it will then create a connection to that MQTT broker. It will start ingesting the Sparkly packets, and it will then start to buffer that real-time data. So if I refresh here, you'll notice that when it gets that new data points, it's going to start and populate my data source. Yeah, so I've done this before. So there we go. There's my flow nodes. There's my water, my wells, and I've got some raw data coming in from this data set here. Cool. Right, so I've got raw data coming from my real-time class. I can do exactly the same for an OPC UA connection. So I can go and connect to an OPC UA real-time source. Again, very simple. Literally type in the IP address of that OPC UA server. I do have a public one available as well. So let's just do that quickly. 167.7. 6, and I did not memorize these IP addresses out of my head. I promise. It's a cheat sheet lying here next to me. It's no security on this guy, so that is literally it. Hit the save button, drag it across so that we can start connecting to that OPC server, deploy it. This one works a little bit different because I need to be able to select which tags in that OPC UA server I want to actually historize. So when it's actually running and started up, I will be able to go and configure it. So you'll notice that there's a little bit of a configuration option here, and that will then go and connect to this OPC server. There's a whole bunch of tags in this OPC UA server. There's a whole bunch of controllers or actuators in here, and I can go and select which one of these tags do I actually want to go and historize. So let's go and just historize any one of these points. That guy hit the historize point, and now we will start buffering that OPC data as well. Right, so just very quickly how we connect to these data sources. We don't script anything. We really try to make it as easy as possible to do that connection. All right. So that's the second part, is just the connect to the different data sources part. Now, the third part is the transformation part. Okay, this is now where I'm going to create all of these weird and wonderful tag calculations that we've got. Okay, so what I'm going to do is I'm going to expand my model here. So I'm going to still work on South Plant. And the calculation that I need to do is I need to only determine how much water am I producing when I was scheduled to run. Okay, now think about it. The schedule sits in the scheduling DB, and the actual flow transmitter values comes from either my MQTT data or from Canary, right? The raw TVQs from that historian. So I need to now do this whole point normalization on those two data sources to actually get an answer of, you know, what is the total only when I was supposed to be running. Okay, so let's do that. I've created a KPI here for my state for the plant. So I've got a KPI already configured here for the active state, the active schedule. Let's open this guy up. This is now in the configuration editor here. And let's see what my plant schedule is looking like for the past few days. All right, so there we go. This is now the schedule that I'm pulling from a SQL database, right? And I'm showing the result as a tag. Okay, we don't replicate this, the data. We're just using this as a pass-through in this data stream that we can use it in further calculations. Right, so it's very simple. I would like to know every time when I was scheduled, so this is all these points where it's 1, I want to know what the actual flow is for those points. Okay, so I'm going to use this tag as a part of my calculation here. All right, let's browse my MQTT source. Let's go into my water system here. Here I've got an FIT for the flow, and I'm literally going to take this tag from my data source and I'm going to drag it into my model here. Right. I'm showing you guys how I'm going to do it by hand. Obviously, there's better ways of doing this when we talk scalability. All right, so this is my source, right? So this is the raw flow transmitter. If I open this guy up and I look at some of the historical data here, there I can see the raw data coming from that MQTT broker that we're buffering. All right, so we now want to marry these two. We want to do this very complex point normalization calculation. So what I'm going to do is I'm going to take the flow transmitter. I'm going to add it to the little calculator icon here at the bottom. And this is now going to be a calculated tag. All right, so I want to know what is the water treated, but only while scheduled. Yeah, that's the end goal of this calculation. Let's open this guy up. Under the retrieval, I already have the raw flow transmitter value. All I'm going to do is I'm going to add the active schedule from my model in here as well. And now I can do a very simple calculation. All right, so the calc, what we're going to do here is the following. I am going to go and, sorry, there we go. This lag is a bit funny from the VM. All right, so calculation is simple. If the schedule is 1, okay, so I'm asking the question, is the schedule active? Then return the actual value from the source tag. Else, just return a null. Okay, so very simple little calculation there. Checking, it's an inline if condition. Checking if the schedule is active. Only when it's active, return the value from that flow transmitter. Else, return a null value. So in this point in time, I'm doing this transformation and doing a little bit of data cleansing before I'm actually going to create a KPI of this data. Validate that I didn't make any horrible spelling mistakes. And let's refresh this guy here. And let's look at a little bit bigger time frame. And there we go. All right, so you'll notice there's these spaces in the data. All right, these are the data points that's now out of the schedule. So if I pop this out and I drag the schedule at the bottom, you'll notice that every time the schedule is 0, those points are not going to be used in my calculation. Cool. All right. So I created a tag calculation. Now I want to take that tag calculation and make it a period aggregate. All right. So now I want to know what's the total for the hour? What's the total for the day? So literally take my calculator tag, drag it onto the hour icon, because remember, part of my model is I know what time context is. Drag it on there, and now I know what is my hourly water production. Drag that onto the daily icon, and now I know what is my daily water production. Deploy it out, and very importantly, the flow engine in the back end will do its thing and do these calculations as every hour comes in. It will pull the raw data, do the calculation, and store the result. All right, let's look at this a little bit in the visualization part of it, just to make it a little bit easier for us to digest. So I'm going to now move just into Flow's native visualization capability. And I've created a little dashboard here where I've created this exact same calculation. And here I can see the schedule versus the raw data that we've got. And then this visualizes it nicely. In the red highlighted sections, these are the values that I'm actually using in the subsequent period aggregations. And there we go. There is my hourly periods. And obviously for periods where I did not have a schedule, I don't have an actual hourly value. Okay. Why is this important? Why is this KPI actually matter? Well, it matters immensely if you want to stick to your maintenance schedules and you don't want to run your pumps when they're not supposed to run while they actually were supposed to get maintained from a maintenance perspective. So we do this a lot, KPIs like adherence to schedule, to make sure that people adhere to the schedules that they need to adhere to. All right. Okay. But this is not scalable, right? if I've got 100 wells, 1,000 wells, Alan, I don't know, your experience in the oil and gas wells is it's a lot, right? There's no way that I can drag tags individually by my hand, one by one, to try and build this model out for me. There's no way, right? I will sit here till kingdom come. So what I've done is, and I've created a dashboard here, and this dashboard is completely blank. There's nothing on it. Okay, it's not broken, I promised. We're going to try and fix it now. But the point is that this dashboard should populate with the amount of wells that we've just identified in Kyle's little higher views that he's created for us in Canary, right? So let's see how quickly we can instantiate and create all of those pump sets for the East area plant that we've just identified inside of Canary. All right, so what I will do in Flow is I will utilize what we call templates, all right? Think about the views in Canary as assets. So you define your assets, what's a pump, what's a piece of equipment. The templates in Flow is more around what is the actual KPIs that I want to measure from my information model perspective. So I've created a template here for my sampling points, and my sampling points are the different wells that I've got. So I've got a pump station. That pump station has related KPIs returning to the pumps. The pump station also has information returning to the production. So what is the total water that I'm treating? And I'm doing exactly the same calculation that I've just done now. In this case, I'm just looking to do the total while the pump is running, but I'm also aggregating it to the total for the hour or to the total for the day. Right. Now I'm going to use this template to instantiate my East plant and do the auto addressing to those points into Canary. That wouldn't have been possible for if Kyle didn't create the views for us. Else we would not have a common way to actually do this. Yes.
Just a question from my side. So essentially you're using the tag naming structure that's been standardized, and you're creating a template for the measures you want based on those standard tag name structures. Is that right?
Correct. Yes. Because again, I don't want to go and populate them by hand or link tags by hand. So we want to be able to utilize that work that's been done in Canary. All right. So what I'm going to do now is I'm just going to instantiate this template. Okay. So I'm going to take this template and I'm going to expand my model by using this template. So I'm going to drag it onto the waterworks section here. It's going to now ask me for a few options. Okay. How many pump sets do I want to instantiate? Now, we know from the data that is in that view inside of Canary, let's just get back to that guy there. If we look at this view and we look at the East plant, there is a very subtle difference between the different pump sets. Okay, so we'll notice that the prefix is exactly the same. The suffix is exactly the same. The only thing that's different is this 010, 020, and 030. This is the sub-area code for these different pump sets. So from looking at this, I know that I've got 3 pump sets that I need to instantiate. Okay. Now, I'm exactly going to do that. I'm going to tell the instantiation tool, okay, cool. I want to go and instantiate 3 of these. Okay. What area am I busy instantiating? Well, I'm instantiating the East plant. What am I connecting to from a historian perspective? Am I connecting to the raw view or the actual view that Kyle just built? Obviously, I'm going to do that. And here comes the little bit of the tricky part, is to define those different subcodes, right? So we've got 010, 020, 030. So I want to go from 10 and I want to go all the way to 30, but I want to step in steps of 10. So 10, 20, 30. So I'm going to just specify that I want to do this in steps of 10, but it's 3 numbers, right? It's 010, 020, 030. So all I'm going to do is I'm just going to pad it. So I'm going to say, please pad this number with 3 zeros. Cool. So this will now do that in the instantiation process. It will go and replace this into the tags that I'm actually pulling out of that Canary system. Let's hit the preview button here just to make sure I didn't screw anything up. And there we go. This is what it's actually going to instantiate automatically. So it's going to create 3 pump sets. It's going to instantiate the sub area code. And then it will build out all my KPIs for my water that I'm busy treating. Cool. So that looks like it's going to work. If I did make a mistake, if I say perhaps I've got 4 plants or 4 and I do the preview, then we will tell you, hey, something is amiss here. You want 4, but you're only stepping to 3 area codes. So potentially there is something amiss with your rules. All right. So we will try and warn you if you do something wrong. I'm just going to change that back to 3. And I am happy. I'm going to instantiate this. So now Flow will go and build out the model based on the template. Yes, Chris.
That was a good question from Brad, that if you, in the future, the Canary model changes, they add the 4th pump, is it going to automatically populate into Flow, or do you need to come back in and change your instantiation count and also that nomenclature that you're doing down below?
All right, so unfortunately for now, Chris, we will not identify a new asset coming in. So what you would need to do is literally just drag the pump set again. And you're going to keep it at instantiation count 1. And literally, you're just going to hard code the area code to 040. That's it.
Okay.
Okay. All right, let's do that. Okay, so these are now instantiated with all my KPIs. The only thing left for me to do is just to tell Flow to actually start processing them, right? Flow also have the capability to backfill. So we are backfilling to the 1st of June. So we can get some benchmarking and some historical KPIs going. So I'm just going to deploy this out. It's going to deploy all of the KPIs. It's going to run through the calculations. It's going to go and run through all the aggregations and the roll-ups. And let's have a look at that. So all I'm going to do now is just see how Flow's progressing doing all of this work. So I'm opening up what we call the monitor. This just tells us how many hours of data it's busy processing. It's always interesting to me. We're only backfilling to the 1st of June, but it's something ridiculous, like 10,000 hours worth of data that we're crunching here. So that's also quite cool. All right, so it's going to run through, it's going to do all the backfilling, it's going to get the data, and you can see how it's progressing through all of that historical data. And obviously when these bars are done, then Flow is caught up until the current time, and then we will just process as time continues. Right.
I've got a question
Now,
real quick, Lenny.
Yes.
On your instantiation, is there a hierarchy connection there? So if I go in and make a change to the template, do I have to recreate, or is there a will it propagate down into the? It
will propagate, Alan. I just want to show the dashboard, then we can break the template. I can show you the instantiation part. But yes, we do have a propagation methodology here, so we don't have to recreate. We do push that change through to the instances of that template. Now, just like I've created the model, I can also use these templates when I create the charts and the dashboards. So I've created a dashboard here for my hourly water production. It's just a time trend, but I'm not using the components from my model to build this out. I'm actually using the components from my template. So if I look at this guy, this is actually built from this total in the template. So I've instantiated 3 of these. So automatically the chart will go and plot 3 charts for me because it can see how many of those has been instantiated. Okay. Now this is the part where I hold my breath and press the F5 button. And let's see. Sure, something's working. Cool. So there we go. We have 3 pump sets instantiated on the charting. Let's just focus a little bit into these 3 different components. So I've got a normal table chart here telling me what is the daily total of water treated. it's extended with the week to date and month to date aggregations of how many liters of gallons I cleaned. I applied a little bit of heat mapping on this. So the idea with the heat map is that I can very easily identify bad periods. So Sunday was a bad period for subset 1. Saturday was a bad period for subset 2. And then Thursday was a very bad period for that. At the bottom, I'm plotting this as an hourly total. So we can see each and every hour, how did I produce? And I'm plotting this against its moving average. So the little dotted line there, that's the moving average of what I'm used to be doing. And every time when I'm dipping below my moving average, you can see these red bars here, that's highlighting that I've got a limit exception on those points. The white line is the regression that we project onto this data. All right, so the white line shows me, well, it looks like I started off very bad on this pump set, but things are improving here. So the regression is showing a positive gradient going into the future. Not so much for these two. For this one in the middle, this has got a negative gradient. So you can see I'm slowly but surely decreasing, and I'm below my moving average. Where pump set number 3 is also looking, they had a very bad stint in the middle here, but it looks like it's beginning to pick up. So it's also above the moving average. I'm also projecting this into the future. So I can now see if I'm going to hit my target at the end of the day. So this solid white line here, this is the target. This target could have come from your maintenance system. It could have come from your production database. What are the actual targets or the nameplate ratings for this piece of equipment? And again, I'm using our projection capability based on the moving average of where I'm going to potentially end up with. So this pump set is smashing it. It's going to get the target here by 10 o'clock. It's already going to meet its target. Not so much for pump set number 2 and 3. The way that it's looking, it's very unlikely that you're going to hit your targets. Okay. Why is this one so high? Well, it's not adhering to the schedule. So obviously it's gonna smash its targets because they're not switching it off from a maintenance perspective. Cool. All right. Now, yes.
That's prescriptive right there. These are your analytics. And I really like this.
That's it.
Easy to understand, easy to see what's happening throughout the rest of the day. Very cool.
Perfect. All right. Now, this is all done in time though, right? Hours, days, months. Obviously, something happened here why these guys had such a bad production in those areas. Maybe there was downtime. So we noticed, or we said in the earlier part of the presentation, that we can also create these event periods for when there's downtime on the pieces of equipment. So I can go and not only create calculations to determine roll-ups based on fixed calendar periods, but I also have the capability to create what we call a downtime event. An event is very simple. You tell it when would you like to start the event. So what is the trigger condition for a start? And then what is the trigger condition for an end as well? And I'm just pulling it from my Canary here. And I can see all my little downtime events that occurred. Great simulated data here. I'm very sorry. But these positive points here is exactly where we've got downtime on this pump. Now, it's one thing to track downtime. It's another thing to add context to the downtime events. All right, so this is where the whole manual concept of adding manual data to the data to provide context becomes very important. Think about downtime classifications for OEE as an example. I would like to be able to classify what was the type of downtime. Was it scheduled? Was it not scheduled? Which department gets the blame? Mechanical, electrical guys. Which equipment was the cause of the downtime? If we can't pull that from the automation system automatically. And then obviously what was the reason why that downtime occurred. All right, so I've created a little mock-up of potentially how that's going to look. So let's go to that. So I do have, there we go, sorry, trigger happy here on my clicks.
Hey, Alan, did you hear about the statistician?
There was a lot of tricks.
Alan, did you hear about the statistician that drowned crossing the river?
No, that did not.
He said it was 3 feet deep on average.
On average. Hmm.
Lenny, what is your VM doing?
Sorry, I'm clicking like a madman because I'm a little bit under pressure here, but that's fine. Let's just, there we go. Cool. All right, so let's look at our downtime classification slot here. So very simple. I've got a manual form that I can now associate these downtimes to. At the bottom here, I've got some unclassified downtimes. So now I'm presented with a nice little drop down where I can say, oh, it was an unscheduled loss, it was a failure. It was the mechanical guys. They have the option to select one of these 3 pieces of equipment. And when they select one of these equipment, they've got the end reason of why that piece of equipment happened. Obviously, if it is another piece of the electrical guys, they can potentially only say breaker trip, drive fault of PLC. So narrowing down the options that people can select depending on who's responsible for that downtime.
I know I don't.
And then we can.
I've got a bunch of questions. I don't want to take. I have one. I'm gonna ask one. Just one.
Cool.
When somebody does a manual drop down, is there a mechanism to show visually this is manual, this was dynamic or brought in from the source?
So there is a concept of what we call a version, Alan. So every time I make a change, we version it up in Flow. So if I look at this history of this downtime event, and I look at the history of it, then you'll see I'm currently at version 2. You'll notice that version 2 has this little yellow dot next to it. Now I could enable this yellow dot on the form, and that will show me, hey, this thing has been modified from the original source that it's been.
That would be good.
Anytime there's a version change, we can show that on the form.
Yeah, that would be good.
So yeah, we keep a full audit trail of this data, and as you can see, it's logged against my name there as well. And then I'm just counting the downtimes, right, based on these classifications. So how many downtimes occurred due to unscheduled losses? The poor electrical guys, they're in the bad here. They've got 37 downtimes associated with them, all on pump set 1, and it's been jamming. So I don't know, maybe a good or a bad thing. But the point is that I can do these different analytics on those downtime counts as well.
Jeff, it's 9:17. We need to get to the transparency piece.
Yeah, Lenny, 3-minute warning. Why don't you?
Okay, cool.
This is great. Flow's got some cool visualizations, but my mandate is not to add another visualization tool to my organization. My mandate is to power other business applications and other machine learning platforms. How do we get the data out of Flow?
Cool. Very quickly, 2 ways.
Where's all this stuff stored? You just did all of this downtime tracking. Like, it's great, but I'm serving this out.
Correct. All right. So we've got 2 concepts. We can bridge it out, the bridging concept, the 5th bubble, and we can bridge it out to another SQL database. We can bridge it out to Canary. We can even bridge it out to an MQTT broker, right? So I've been pushing this data out to Canary, and you can see there's my projected calcs that I've been pushing to Canary. So we didn't even realize it, but as Kyle was building that stuff, it was automatically consumed. Then we also have an API, right? So we do have an API that we can go and get the data out of. So the API is documented here. So I can pull the data, I can pull the information, I can even pull the entire model that I configured in the API. Now, where can I use this? Well, I can use it potentially in Power BI. So this is don't judge me for my Power BI skills, but this is a little bit of a mock-up that I've done in Power BI. But the cool thing about Power BI is I can now use their nice slicing and dicing capability, right? So here I've pulled through all of my folders, my metrics, my KPIs. I can now very easily go between the different plant sections here and say, oh, I want to see each plant 2's total, and it will update. No, wait, let's go back to plant number 1. and let's select the total and let's see where the daily is at. So I can very easily now utilize this, and this data is pulled from Flow by using the REST API.
Got it. All right. Lenny, that was a lot. Chris, is
I
your
know.
hand spinning?
I'm sorry, guys. I hope it was insightful how we do the transformations, and then potentially how we can get it out from a visualization perspective.
Chris, Brandon, what'd you think?
Oh yeah. Brandon?
That's looking up. That's looking awesome. It's the first time I've got to see a real good view of how Flow works. It's a pretty awesome tool.
All right. Well,
Yeah,
let's
I
talk.
want to just take the test real quick. So model,
Yes.
transform.
Yes.
Nope, I missed one.
Oh, connect.
I missed it. I looked. Connect, transform, visualization, and bridge.
And bridge.
There we go.
Yeah. So the key, I think, here with what we're trying to show from the integrate live side is avoiding platform lock, right? So yes, you are bringing data into Canary. Yes, you are bringing data into Flow, but you're not forced to stay inside of those tools to do your analytics. It's all about getting that bridge of that data out and gaining from what you've built inside of each of those platforms. So Kyle, you mentioned the Canary calcs, the Canary modeling, the views, they're shared as part of that API, right? You don't lose that work. Flow then takes the work that you've already done and adds to it. But again, nothing is locked inside of Flow. It's now all made available. Let's talk price. Chris, Brandon, what does a solution like that cost if someone's trying to build it on their own at the enterprise level? What's the hours of work that are being saved? Well, what we saw today, right? Walk us through it, Chris.
Yep. And the purpose of this is not salesy.
Right.
We're not selling you 1,000 measures right now of Flow or 7,000 tags of Canary. Not the point in the least bit. This is something that we use in our own personal work. We use Canary and Flow quite often. And the purpose of today was just to show you a thing that we use to do real projects in water, gas, solar, manufacturing, and then to just be transparent and say like, okay, what you saw, it wasn't $1 million. It also wasn't $5,000. It's important that you can just see what this is, that if it makes sense for you. And again, we don't get any kickbacks. We don't get any of this. Literally showing it off because we like these solutions and we want to share it with the community. So that's it. So on the Canary side, what you see in just an average tag count size, about 7,000 tags. You can go lower, you can go higher. There's packages, all the way down to 1,000 tags or less. But with those tags, there's no limits on logging. You can do multiple sites. You can bring in as many data sources as you want. You can have unlimited virtual views. Comes with the open API. So that dollar is based very specifically on the count of tags. Decrease the tags, decrease the cost. And that is tags coming from your PLCs. Yes, there is public pricing available. You also can talk with Kyle or with Vaughn and Lenny, and they would be able to get you very specific. So on the Flow side, they work in terms of measures and events, and it will take you a moment to use to it. And this is just our honest of, we probably are struggling with it like you do too. And so we put this nice handy calculation down at the bottom. We have found that there's a correlation of it takes about roughly 15% of your total historical tags. So if you have a 7,000 tag Canary, you're probably going to have about 1,000 measures. That's a good scale of that. As the systems get larger, that percentage gets less. So if you have 50,000 tags, 100,000 tags, you're going to have far less than 15% measures. So that could be a future discussion on how measures are used and how events are used, but just know that a correlated software setup with Flow for this was about 18,500. And again, those come down as you have less measures or less events.
Hey, Chris, I made a mistake. Lenny asked me yesterday to make a correction on this, and I did not. He said, hey, Jeff, the pass-through tags are not unlimited. And sorry, Lenny, I completely forgot. So if you wanted to go for bigger scale and go unlimited, both Flow and Canary do unlimited enterprise offerings. Let that be said, but that particular price point, I don't think represents an unlimited pass-through tag. That's part of the measure. Sorry about that, Lenny. And
I saw it on the internet. Doesn't that mean it's true?
Abraham Lincoln said so.
Kyle and Lenny, there was a question about trial licenses.
Yeah, absolutely. Feel free to reach out. We offer free demo software, and I'm happy to walk people through any particular projects they're working on.
Cool. From our side, you can download Flow from our website. It is in a trial or demo mode for 90 days. That will give you 500 measures to play with and 50 events. But if you need to have it for a longer period, please just give me a shout and I will happily assist with a longer period demo license as well.
So somebody could try exactly what you guys built today on their own with some trial licenses. That's cool.
Correct. There's also some demo models that we have on our websites on the download link that can help people. We've got a little Juice Factory demo that you can download and import and have some stuff for and just hook it up to your historian and see how some of these calculations that I've been demoing has been done as well.
Great. We did have a question come in. So Chris, Brandon, Kyle, Lenny, Vaughn, we'll put you kind of now shift you over to a panel position. Alan, I'm pretty sure has a few more questions he wants to ask. So we're going to not use Wonder on the backside today, just because we're going to use all 90 minutes of our scheduled time. But let's spend our last 5 going through some questions. Jeff from over at Penn Tech College has asked, hey, I'm on the 4.0 solution side a lot, where UNS, the concept of this unified namespace, is mentioned a lot. How does Flow or how does Canary work within that UNS environment?
Hey, Jeff, can I give an example of how we did this at Era?
Yeah, please.
So obviously the unified namespace, what you're hoping to do is get a central point where you're publishing out that tag and the context, and then you subscribe to that, and you're always using that source of truth from the source, right? It gets a little more complicated because if you're not publishing from the actual PLC, then you're taking a tag from a PLC and you're moving it to, say, ignition, and then you're creating another tag, and then you're building a UDT or whatever, but then you can publish it out. So I want to be clear that what we did at Era it's not at the level that we would like to be at, which is it would be awesome to be able to publish from the PLC to the broker, have Ignition, Canary, Flow, all subscribe to that same tag and use it. However, a really good option is what we deployed at Era, which is we had all of our PLCs talking to Ignition. We made sure that the context was accurate and correct. And then from Ignition, we published to a broker, and Canary connects to that broker. So I'm not creating another tag in Canary. I'm publishing or subscribing to that broker, bringing the tags in from Ignition. Flow can then also either subscribe to that same broker, or it can connect to Canary however it wants to do it. But the point is that through the entire stack and through the entire system, that same tag, the same naming convention, the context, the scaling, all that carries with every system is all the same.
Anybody else want to add anything to UNS side? One of the things that I see UNS really standing tall in is this concept of real-time data, right? So where that MQTT is a broker in the central hub of UNS, where you lose that hub spoke model is when applications start needing historical data. Now they're reaching out and they're going to potentially 5, 6, 7 dozen different locations. I think of some of our, upstream oil and gas, great example, right? You've got all of these different databases that have historical data. I would actually, on my side, position Flow as like the UNS plus, meaning that it becomes that UNS for historical registration. So if I can, that concept of that pass-through tag in Flow is what hit me is the most exciting concept, because if you think about it, and I really want to dive into this more next Wednesday on the rundown, but if you think about it, Flow could connect to Pi historian, Canary historian, PhD, all of these different historians using these standard protocols. It could, where Canary is not already standardizing naming, Flow is standardizing and helping standardize a model. And so essentially I could query Flow for any history from any of my historians on a corporate level without ever having to hit those historians. Looking at you, Brad Thomas, if you're still on the call, I know that solves a problem for you. I know that solves a problem for a lot of large enterprises. And that's why we were excited to bring these technologies forward today. What other questions do we have?
I don't know if it's not a question, it's more along tying on to what you said, which is, right, if you could start from scratch and redo your control system today, you do it much different than you did 20 years ago. However, having that methodology to be able to put a system in, collect all this unnormalized, uncontextualized data, bring context around it, becomes very impactful.
Yeah, very good. Let's wrap it on there, Chris. And Brandon, why don't you close us out with some final thoughts? And we're going to have everybody back next Wednesday for the rundown. Is that right?
Jeff, is there a place that somebody could send a question between now and the rundown so that they can get that question answered in the rundown?
Yeah, that's a great idea. Yeah, please.
Great live on LinkedIn. Join if you haven't.
Yep. On the rundown, we're going to dive really deep into these enterprise architecture best practices, what we've seen in our experience in the field. We're going to meet Jen for the first time in the community, and we are officially now no longer using Zoom for our rundowns, but we are streaming them using StreamYard. And thank you to everybody who helped push us over the numbers from LinkedIn. We'll be streaming it on the LinkedIn and the YouTube live page for Integrate Live. Got some fun, exciting things to announce in the rundown next week. Thank you for joining us. Chris, Brandon, thank you guys. You did such a great job as guides. I appreciate you taking on this heavy topic today.
Thanks for having us. Appreciate being invited.
It's fun.
Good job, everyone.
All right, well, we're going to sign off. Thank you so much for joining us. Thank you for being part of the community and growing with us. We hope that you've leveled up your analytics game a little bit today. And we look forward to continuing the conversation on Wednesday at 11 a.m. Eastern Standard Time. We'll see you live.